Thank you. Welcome this evening. My name is Jörgen Buder and I work at this crazy office at the Purple Scout. Except these things, of course, we do a lot of development and we work with a lot of different technologies. If you read my presentation, you know that this will be a rather practical demonstration of something that I've done that is one of my passions, which is actually besides the work that I do at Purple Scout, except of course the development itself. Let's end this one. Does anyone know of a trail runner named Ida Nilsson? Anyone? Nope, never heard of her, which is so sad. Let's see if I can run this. It's the girl coming here, over here. She's a trail runner, Swedish of course, Ida Nilsson, and she ran the Ultra Trail Marathon Mont Blanc. This race is called CCC. It's 100 kilometers long. You run up and down the mountains. So 100 kilometers is pretty much, as you can see. And this is actually not the longest run that they do there. The PTL, I think, is about 270 kilometers and runs over 100 hours. Now, this is also one of my passions, trail running, running trails, running off trails, and running far distances. Through my work, obviously, but also many years ago, I started exploring neural networks. Actually, first time was in 1990, which was pretty early at the time because the computers weren't very fast. And since then, it has kind of like been in the background all the time, this interest of mine. Now, computers are much faster, and also we have like real applications where we can use some data and input in these rather fast neural networks and actually do something with it. So this demonstration, I will show you what I've done. I have a long way more to go, and this is kind of a hobby project. It will not be about mathematical methodologies or anything like this. I will just show you how I'm thinking when I'm trying to train my network to detect movement through a trail running. The main reason why I did this is because when I'm out running, or if I'm running someone else's trail, like for instance Ida Nilsson, I would like to know in what kind of ground she's running. If it's technical, if it's asphalt, if it's sand, if it's like no trail at all. And these things can actually be detected by, of course, some of the GPS, but those are accelerometers that you can have on your body. And I'm sure that you have heard about different brands making sensors that you can mount on your shoes when you run, and they can actually tell you what kind of technique you're using. And obviously, if you have been running 100 kilometers, your running technique is not as good anymore. So my idea is to have this, feed that into a machine learning system, back to the runner to tell the runner that, okay, you need to slow down or you will not be able to rake it 100 kilometers. All right, so that's the main idea. I've made a few implementations of machine learning, neural networks. I'm not talking about AI right now, because AI, I think, becomes more of a philosophical thing about how to, emulate some sort of artificial intelligence. So I'm talking about machine learning. And during this time, I've tried different things. For instance, I've tried to predict weather. I'm a hang glider, so I wanted to predict weather. I inputted, big data, a lot of different data parameters into a actually deep neural network at the time. And very quickly, I could see that I didn't really get the result that I wanted. And after trying that, I tried some other sort of data, and I tried to strip down the data. And pretty soon, I understand that, okay, so the data we input into the machine learning systems is rather important, okay? What it is that we input and what we actually want out on the other side, which brings us back to something we're not going to talk too much about today. But doing these things about machine learning will, again, be about requirement specifications. What we put in and what we want to come out from it. I'll leave it at that because we could talk about that much more. So after some time, I came to the conclusion that trying to input a lot of different data, like for instance, wind speed at that time and text from forums who actually tells that I'm going to fly or not, temperature, humidity, and so on, becomes like so much data that when you try to get something real out of it, it doesn't really become data that you're consent with. Sometimes it works, sometimes it doesn't. And from a return of investment, if we're thinking about what company is actually going to pay us to do, That's not optimal. So after some time, I learned that the best way to do this is to modularize machine learning. So try to, for instance, predict things like, okay, so wind speed together with temperature, together with maybe a third parameter, feed that into a machine learning algorithm, and then make some basic predictions on this. And then take other data and use a different machine learning algorithm or a different neural network and make predictions on this. And then after that, try to combine these in maybe a more of a artificial intelligence way, where you maybe not are using machine learning at all. So what I'm saying is that I've learned that I've reached better results if I try to make smaller portions. And I know that Ericsson outputted a lot of blogs right now. They call it what is it, thin AI and broad AI, something like that, if you've seen that. And basically this here is going to be a thin idea, very specific thing that I'm trying to predict, all right? And I'm going to demonstrate this. This one here, this is Strava, one of the different services that you can use to log your runs. This is a run that I did in May in a Proper Scout conference. We were in Palma, actually a little bit southwest. I ran together with one of my colleagues, basically up the mountain over here. We were going to run up the mountains over here, but there were like 3 surveillance cameras and 1 sensor, so we decided not to go there. So we went down again and run around here a little bit. And this is, compared to here in Skåne, this is a little bit more mountain, a little bit more technical trails. This is my input data, in which what I'm going to show you later is my mock-up of this run over here. Don't know. It's Strava, ask them. It's the pace I'm looking at basically when I'm doing this, and elevation gap, not sure. I'm sure you can find it somewhere. Now, before we start here, maybe I should just say that I'm using a JavaScript library called Synaptic. Obviously, we can talk about performance, but in this case, I'm using, as I said, thin AI or a specific context of machine learning. So I'm not going to do any deep learning networks. I'm going to use just one middle layer. I'm going to use a simple input layer and a very simple output layer, because I just want to make some sort of basic production and basic pattern recognition. There's a lot of things you can do with this. I'm not going to go through that, but you can go in and have a look at what different kinds of quite complex things you can do with Synaptic. I've chosen to use this one in Node, so it runs in the backend. And this actually already runs at the server and actually gets input from a GPS, which is not a phone. So I can use this today already, for real. Taking a quick look at this very simple machine learning library. As I said before, I'm not going to go deep into all these algorithms and settings and so on. But basically, obviously, you have to set up your layers and your network, and then you have to train it. You have to input the data. And as I said before, you need to have a specific idea about what kind of data I want to input to be able to detect something. And then after that, of course, I want to test it, and then I want to run it for real. All right? This one here, this is basically what you need to do. Define some layers, networks. You need a trainer, which is part of this library. And here I define my basic network. I have 10 input layers. I have 50 hidden layers and 1 output layer for the moment. Now, the reason why I do this is because my aim here is to detect something very simple. Am I running uphill? Or am I running, or maybe I'm not running uphill at all, it's flat, or am I doing a downhill running? Or maybe I'm doing a hard uphill running. So I'm going to try to detect those different things from real data eventually, but first from some mocked up data that I'm going to give it. I need to think about this. I've seen that many times. I spend like 50% of the time thinking about how do I prepare the data that comes into my machine learning my machine learning neural networks, because if I don't do that, it's going to be chaos. So what I've done here, I'm going to scroll down just to show you how I'm thinking here. I'm inputting delta values. So this is GPS position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is the delta value of the altitude that I'm having. So I'm mocking up and saying, okay, so this is 1 meter higher than before, this is 1 meter higher than before, 2 meters higher, 2 meters higher, and so on and so on. So I'm kind of mocking up. Okay, so I'm going to do a trail slow ascent. I'm running slowly uphill, okay? Now this is the definition of, this is the training set that I'm going to give the network to be able to train it. And if we just take a look down here, I'm also going to give it something like this, because I want him to output a 1 if it is a slow uphill running, and a 0 if it's not. All right, this is of course a very, very narrow case, because I want him to detect much more things. Yeah. No, it isn't, and not the length either. So there's a lot more things you might want to think about here before you do that. But then again, when it comes to machine learning, we want it to be a little bit, fuzzy logic, a little bit like, does it matter if it's like slow uphill from a certain time, or is it actually the distance? But these things are adequate questions that I need to take into account later. No, it is not. I'm just taking 10 random points, which could be way wrong, of course, but no, it's not. And then I take these things and I train. Now here's a few parameters. I'm not going to go into them, but basically training a machine learning network, you need to iterate, you need to have a rate, you need to have some other settings to be able to train the network. And as I said, this is a simple feed-forward network. It's not something special. Every one of the neurons in the top, the 10 in the top, goes to every one in the middle layer, to every 50 neurons, and then every one of them goes to the 3 output layers. Or in this case, actually, the 1 output, because as you could see in this one here, I'm currently having 1 output, just to be able to show you this training here. So I train it, and after I train it, I'm going to ask him, with the exact same data, what kind of category I'm getting out. And the same thing here, what kind of category I'm going out. Category meaning no uphill running or uphill running. And in the end, I'm going to give him some random data. Random in the case that I'm not giving him exactly the same data that I trained him with, but different data, because this is what I actually want. I want him to be able to kind of detect the slow uphill running, no matter what the actual delta values are, as long as they have kind of the same distribution. Now running this code, I've tried to enlarge this one as much as possible so we can see it quite well. Now, here we've now run this code, and basically what we said that we wanted to input some data with a slow ascent, uphill running, and the first category reacts with 0.996, which is basically, we've detected a slow uphill running, and if we have no ascent, we have 0.006. So basically what I've done now is teach it that this is not 000 as we had before, this is not an uphill running, however this one is probably an uphill running, right? Now this is kind of where some of the experience I've had with teaching the neural networks these things is that you kind of have to take it bit by bit. Just inserting everything at the same time kind of ends up in chaos. You might think you're getting a good result, but in the end, when you tweak it a little bit, it doesn't give you at all a logic, and that's when you kind of get lost. And then you can spend hours, weeks doing nothing, not knowing where you're going. From here, obviously, I want to evolve my algorithm or my neural network. So the first thing we're going to do here is something very simple. We're going to teach him something more. For instance, as you can see on the data over here, we have expected bumpy road. And in this case, the bumpy road is kind of like going up a lot, going a little up, going up a lot, and so on. So it's not a slow ascent. It's way more bumpy. And in this case, it actually detects this one as a slow ascent. But I don't want that. So I want to teach him now that this is not a slow ascent. This is something else. To do that, obviously, I have to enter this kind of data right here in the training set. So what I'm telling him now is that if it's a bumpy uphill climb, then I also want that to be a negative. I don't want that to be defined as a slow ascent. Save, which I usually forget. and then we run it again. And as you can see now, we evolved the network a little bit, and now we actually come to the expected bumpy road is now 002. So now I've taught him that, okay, so this is not an okay input range or array, all right? Now, obviously, this may take some time if I want to, teach him everything, but still, with the experience I have, taking small steps, just like with any code development, is actually a good idea. Now, obviously, when you have come this, after a while, you'll see that, okay, so now I can take larger and larger steps in what I want to learn. And this code here also contains, because now we're just detecting one thing. We're just detecting a slow ascent, a slow uphill running. But we may want to, of course, this happens every time. We may want to, for instance, detect a hard uphill running, which is much steeper. And I also, in this case, want to detect a descent, slow downhill running. So I'm going to do that. But I need to add categories. Okay, we had just one before. Now I want 3 neurons to be the output layer, which is basically different categories. So I'm going to add all these right now. This first here, as you can see now, 3 out. I'm going to change this one so we have 3 neurons going out. And I'm adding this one, which is a trail slow descent. So I'm expecting that if this is kind of what we're seeing, I want that one to be 1. This one has already been defined. It is the first one. And I'm also going to add a hard ascent, steep uphill running. Right there. Let me see, so I did everything right. I need to do that. Okay, so now I've added a few things. So I added two new categories, and I've added some more test data into this. Obviously, when we do this, I also want to see that it actually does output the right thing. So I need to activate a few printouts. 1 second. All right, that should be it. Let's see if it works. I think it did, I hope. So now we have 3 categories. We already have slow ascent that we had before, that was the first category, 994. And obviously the other category shouldn't be reacting in this case. Otherwise we have to teach him more negatives. We have no ascent here. Nothing happens if we are around 0, we're just running. And then we have a steady high ascent, which is the second category, which is in this case also correct. You'll have to trust me, looking back at the code. And then down here we have a steady slow ascent, which was, steady slow descent, which is also one of the new categories. So now we've done that, and I'm inputting down here different things, same things as before. Expected steady slow descent, which is now not, this is not exactly the same array that we had before. This is different kinds of numbers, and I'm expecting that one to react, which it does. The slow ascent over here, you can see, reacts. We have a little bit less there and a little bit more there, which means that, so this one is probably a steady slow ascent with a little bit of, let's see which one that is, high ascent. So it's like a little bit steeper than the slow ascent, but not as much as the high ascent. All right? And then, of course, we have the expected bumpy road that we said and taught it before, that this is not a reaction. We don't want to know when it's a bumpy road ahead. So what I wanted to show you here is how I try to teach the neural network bit by bit. After some time, you get more used to it, and you can add more data, and actually you get a little bit bold, and then you add lots of data in there, and then at some point, you're lost again, and you have to take a step back. Now, this is just mocked up data, as you can see. I've come up with the deltas myself, but obviously I want to test this one with something real. So what I've done now in the next prepared file over here, kind of like Tina Nordström when she's making some food, I have exactly the same stuff as we had before. So I have 10 input layers, 50 middle layers, and 3 output layers. I have the same sort of, detecting the slow ascent, the hard ascent, uphill running slow, uphill running steep, and also the descent. But now I'm taking the actual values that I'm teaching him from the trail that I run before in Palma. So I've gone in there, I'm marking 10 points, and exporting that as a GPX file, and I'm inputting this as a training array. instead. And I do that with the same thing. And obviously I can do a lot of things here. Now I can go in and, I know where I was running. So, okay, so here was like a lot of routes and maybe not a trail. So let's take 10 of them and say this is like, I don't know, off trail running, and this is a hard uphill running, this is a hard downhill running. I can teach him all these things from real data. And this is what I'm going to do here in this code. I'll just briefly show you how this is done. I'm using here an array of 10 points, 2 meters downhill running, GPX. I'm reading it obviously, and I push it into the testing arrays that I want to do. And so I continue to do that with 4 meters. This actually is 2 meters down and 4 meters down. So, and then we have the 2 meters uphill running as well. And we have the 8 meters uphill running, and so on. Now, in the end, I'm taking a larger portion of this file that you could see, where I'm actually running uphill a rather steep hill. I'm going to show you a picture of that one before we run the actual end demonstration here. And this, of course, I also read in. And this is what I'm going to feed. So basically what I'm doing down here, I hope you're with me here with all the development stuff. After training, down here, I'm doing a set interval where I'm looping over each 10 points of where I'm going. So I'm adding a point in, getting rid of the next one, and then running it through the neural net and outputting a text saying that, okay, right now you're doing a slow uphill, right now you're doing a hard uphill, right now you're doing nothing. All right? So this is what I'm going to do. To show you what this is actually run, where this is executing at, let me go back here. Let me go to this one. Right here. This is the run that I'm going to do from here up here. So this is actually up. I'm not going to show myself how I was looking at that one. I'm going to show Martin from the back, my colleague. So this is an uphill. It's about, this is actually halfway up. So this is about 15 more meters until we get up there. And as you can see, it's quite technical. Okay, so this is not something maybe you sprint up from. Okay, let's run the actual mock-up here now. So I have a web page that will show us on the map when it's running. And I'm going to run the code. Okay, as you can see now, it looks a bit different. Okay, this is the actual data that comes in. Okay, this is the trained data from the real things that I've run. And then now here I start to iterate over this path, this trail. And as you can see right now, he thinks that I'm doing slow uphill running. If we take a look at the page presented, it takes 10 seconds, I think, before he actually gets into doing that. This is where it's going to fail probably, in demonstration. Okay, pretty good. I don't know if you recognize it, but this is the trail that I was running here, up, and this is the actual real uphill technical running I'm doing. So we're going to have to give it some time, and during that time, I'm going to show you this little thing over here, which is an Arduino. And this is typically something that is sold today. There are small sensors you can buy and attach to your shoes to be able to detect things like, for instance, how you're running. And this is something that I also will hook up to my phone, and that will send accelerometer data, so it knows how I'm moving my hand, or maybe even my feet or my hips. Because from that data, I can see if I'm tired when I'm running, if I'm running too fast, if I'm running not efficiently enough. And as you can see here, it actually reacts to the different kind of movements that I'm doing. And this is going to be hooked up. Now, as you can see over here, I'm moving up the hill. And as you can see right now, he has started to detect that now it's a hard uphill running, which is correct because it kind of started here. This is when it was getting hard or fun, depending on how you see it. And then it's going to go up here. And after some time, he will start to detect and say that, okay, so this is actually just slow uphill running now. Personally, I think I need to, retrain him, because I think it was hard uphill running all the time. It was really hard. As you can see now, yeah, exactly. In a year, maybe I'll say it's easy peasy. And now it's slow uphill running again. When we're coming here, excuse me for the not perfect line over here. It's fed into an IoT server. at Purple Scout, but I'm feeding it a little bit fast and not sequentially. And don't care about these things. This is not true. So this is what happens. So this is the actual results. And this, of course, what I want to do with this is I want to read this as well as more data that comes in from more sensors. And in the end, if we go back to the the vision I have about this, is that the phone in my ears is going to be an assistant for me, telling me, because if I'm going to do what Ida Nilsson did, running 100 kilometers, the assistant's going to have to tell me that now you're not running efficient enough. Maybe I need to lean more forward, or I need to take it easier. That's really hard in the beginning. You always go too fast in the beginning. To keep to save your strength to be able to go that far. This was a 20-kilometer run that we did up there. I tried to do an ultra run last year. I only came to 32, so I'm kind of disappointed. So this year I'm doing Kullamannen, so-called the double death, which is 44 kilometers and about 2,000 meters height climb. I don't know if you know Kullaberg, but there's a few mountains over there. That's it. I hope I gave you some sort of information that is valuable for you. The essence that I wanted to give you is that take small steps when you do these things, because otherwise you might get lost doing all these things. And make it simple. Don't try to make like large, multi-layer, deep machine learning networks, because it just tends to be complex. Unless, of course, you've been doing this sometime, then you can step things up. All right. Thank you very much.